Number 1. The temperature coefficient of resistance of copper at 0 degrees Celsius is 0.00427. The resistance of a coil of copper wire is 8.82 ohms at 24 degrees Celsius. Determine the resistance at 0 degrees Celsius, B at 42 degrees Celsius. Before we start solving this kind of resistance problem related to temperature, let's recall some basic formula. If we recall our formula in this circuit, our resistance R2 over R1 is equal to T plus the final temperature over T plus your initial temperature, where your T is your inferred absolute temperature. So this is our formula number 1. We have a formula number 2. This is equal to your R2, which is your final temperature, over R1, which is your initial temperature, is equal to 1 plus the temperature coefficient of resistance times the change of temperature, which is your final temperature minus initial temperature. This is your second formula. Don't forget that your temperature coefficient is equal to the 1 all over the absolute inferred temperature plus your initial temperature. Usually the value of our inferred temperature for copper, that is equal to 234.5. So that's why it's easy to recall in copper, because you only count 234.5. That is your inferred temperature for your copper. How about for your we only need to recall 2, the copper and the aluminum, because it's the basic type composition of wire. And for your aluminum, that is 236. Okay, so don't forget this constant. Okay, so we have 3 formula for our resistance related to temperature, and 2 constant for copper and for aluminum. Okay, moving on with your problem. Okay, so determine the resistance at temperature at 0 degrees Celsius. So resistance. So for our letter A, we need to determine the resistance at 0 degrees Celsius. So let's recall the formula right away. Our formula number 2. Since if we evaluate the given, the temperature coefficient is already given, and we have the resistance of copper at 0 degrees. It means that this is your initial temperature coefficient. 0 degrees temperature is your initial, and the resistance of coil copper wire is 8.82. So this is our final temperature at 24 degrees Celsius. So this is our T2. So how about our initial temperature? Our initial temperature 1 is our 0 degrees Celsius. Okay, so this is our temperature coefficient. Okay, so let's recall the formula. Let's use the second formula. We have your final temperature over initial temperature is equal to 1 plus temperature coefficient times your change of temperature, or final temperature minus initial temperature. Okay, let's review our given. We have the value of R2. Yes. Determine the resistance at 0. This is our initial resistance, so this is unknown. One constant temperature coefficient given, yes, 0.00427. Our final temperature is what? 24 given. Initial temperature is 0. Okay, so let's substitute the given. So we have the 8.820 ohms all over our R1, which is our unknown, 1 plus our temperature coefficient, that is 0.0427, times our final temperature, that is 24 degrees Celsius. Our initial is 0. So solving for your R1 is equal to, using your calculator, your R1 is 8.000145127 ohms. Okay, so for our second, so this is our temperature at 0 degrees Celsius. So I'll save this to our alpha A. Okay, moving on to your second problem, we have our at B, solve for your a temperature at 42 degrees Celsius. So we are tasked to determine our final temperature here. So we have the same formula. We have our R2 all over R1 is equal to 1 plus temperature coefficient times change of temperature minus initial temperature. So let's check our given. So we have the value for our R2? Do we have a value for R2? That is our unknown. How about for R1? We already solved it at 0 degrees Celsius. This is our R1. X1, how about for our temperature coefficient? Still given. Final temperature, we have 42. And we have at 0. Okay, let's substitute the given. So we have our R2 all over our alpha A. Since we solved it for alpha A, we stored it on alpha A. 1 plus our temperature coefficient, which is given 0.00427, 42 final temperature minus 0. Okay, so therefore your R2 is equal to your R2 is equal to your final temperature. R2 is equal to 9.4348911154 ohms. Okay, so this is the value for your resistance at 42 degrees Celsius.